You're all fine. What the different atom models show? In the space-filling model of a molecule, atoms are represented as solid sphere. You see, it is completely different from the Bohr model as well as electron cloud model, right? It is just shown as a ball over here, sphere shape it has, each and every atom. You are not able to see the subparticles of the atom in this model. The spheres do not show the parts that make up the atoms. You see, you are not able to see the neutrons, electrons in this model, but this model clearly shows how the atoms are connected to each other. You see, actually the connection of the atoms are clearly shown. Why it is that much important? Because the atom which is connected to carbon atom over here, for example, if it is in the below, not above, then it completely change the chemical and physical structure of this substance. Okay, for example, here completely you are able to understand that where the here hydrogen atoms are located, where is the carbon atoms are located into this phospholipid. For example, here where is the nitrogen atom, where is the oxygen atom. You are able to see all places under this model. This is called space filling model. You are able to see here carbon dioxide. There is just one carbon and two oxygen. Okay, two oxygens are connected with the carbon atoms side by side. Okay, you are able to see the position of the oxygen on the carbon atom. Bohr models show electrons in energy levels, each of which can hold a specific number of electrons. The energy level furthest from the nucleus is called the outermost layer, energy layer. This is actually what? The valence electron. Okay, outermost energy layer is called valence electron. Whatever electrons are present on the outermost layer of the energy, it is called what? Valence electron. Electrons found in the outermost layer, energy layer of an atom are called valence electron. I ask how many electrons this valence electrons this atom has. You have to calculate. How? Like this: 1, 2, 3, 4, 5, right? And 6, 7, 8. You see, 8 electrons are present on this atom. It has 8 valence electron. We can say it means that this atom doesn't do any chemical reaction with others. It is so rare to make chemical reaction because it is little outermost layer is 8. If it is 8, it doesn't make any reaction with the other atoms. Now there is a video, please watch about the it is about the
electrons present in the outermost shell of an atom are called valence electrons, and the shell which valence electrons occupy is called the valence shell. A molecule is in general a group of 2 or more atoms that is chemically bonded together. Atoms combine chemically by external forces such as heat and light. This leads to the formation of molecules. During the formation of a molecule, atoms lose their valence electrons or gain electrons from other atoms. For instance, if 2 pieces of wax are to be joined, they are heated. After heating, the 2 pieces are pressed together to form a single structure. Here, heat is the chemical factor which is responsible for joining the molecules of wax pieces. There are 2 main types of bonds, covalent and ionic. If a molecule is made up of atoms of the same element, it is called a homoatomic molecule. If the molecule is made up of atoms of different elements, it is called a heteroatomic molecule.
As you are able to see here, guys, each and every atom, actually most of them, get energy from outside to make a bond between them. Okay? As you have seen over there, flame releases its energy to the waxes, and that's why they melt and join together. Like that, each and every atom receives, mostly they receive energy from outside to make the bond. Okay, when you think opposite, it means that broken down bonds releases energy, because when you make the bond they get energy. It means that when we break down the bonds it should release the energy. Understand? That's why actually when we break down the bonds between the atoms in our food, in our body, okay, it releases energy. That's why we are warm up. Okay, that's why we get energy. That's why we are able to walk. Understand? We break down the bonds between the atoms in our food. Same thing is here as well. Okay, if you want to produce oxygen, for example, water molecule, definitely you have to give energy. As you see, different type of the atoms can come together to make molecule. Okay. Here, elements in the same group or vertical column have the same number of valence electrons. I explained before actually. You can use the group number to find the number of valence electrons in group 1, 2, and 13 or 18. How is that? Look at here, for example. There are, elements on the periodic table, The first group has 1 valence electron. The second group has 2 valence electrons. For all elements same. Okay, for the 13 group here, it has 3 valence electron. Okay, 14, 4, 15, 5, 16, okay, 6, 17, 7, and 18, 8 valence electron has. Okay, the all elements has, same number of the valence electron, except helium 2, the rest of them has 8 valence electron. But, if you are able to look over here, all of them has same number of the valence electron. It means that outermost layer of those atoms have same number of the electron. Now over here, look at it. There is no simple rule to find the number of valence electrons in groups 3 to 12. From 3, third group, to the 12th group, there is no simple rule. You have to calculate one by one for each element. Okay? But you are not responsible for those elements to find, okay? But it is easy to find. You are not supposed to find it. Okay, let me find for you one example. Over here, there is an example actually. I will explain for just carbon, and you will find the nitrogen and fluorine, the valence electron of the nitrogen and fluorine, and you will give the answer in the group discussion. Now look at here. Determine the number of valence electrons in atom of carbon, nitrogen, and fluorine. Now where is the carbon? Here. Nitrogen and fluorine is here. I will explain for you the carbon. Carbon here has total 6 electrons, right? 6 protons. It means that it has 6 electrons in the neutral form. Now, carbon atom has one layer. In the first layer of the electrons, okay, in energy level, it has 2 electrons. In the second energy level, there should be 4 electrons because 2 are already put in the first energy level. In the second energy level, how many remains? 4. 1, 2, 3, 4. You are able to see there are 4 electrons on the outermost layer of the carbon atom. That's why its valence electron is what? 4, we can say. Okay, you will find for nitrogen and fluorine, and you will give answer in group discussions. How about the next one? Yeah, here. Why do atoms form bonds? An atom tends to form bonds if its outermost energy level is not full. Okay? Atoms that have fewer than 8 valence electrons, except for helium, because helium has 2 electrons, and in the first energy level of the atom there should be 2 electrons, and it is fulfilled for the helium. That's why it is not necessary to make any reaction for helium. Okay, And it is not necessary to make it 8 as well, because in the first level the atom need just 2 electrons. Okay, 8 valence electrons do not have a full outermost energy level. If there is no 8 valence electron on one atom, there should be one chemical reaction to fulfill the outermost layer of the energy level of the atom to 8. Okay, to fulfill the valence electrons to 8. If it is 8, okay, then that atom doesn't make any reaction. Mostly it doesn't make any reaction. If it is not 8, mostly it makes a chemical reaction. These atoms gain, lose, or share valence electrons to form bonds. This is important. Actually, in here you will be able to understand that bonds form by how many methods? 3 methods. 1, gain electron, lose electron, or share electron. Okay? Gaining and losing electrons is one type of the chemical bond. Sharing electron is another type of the chemical bond. The name of those chemical bonds are, ionic and covalent bonds, but you are not responsible for the names of those bonds because it is not mentioned in your book. Okay, but you have to know that the bonds can be done between the atoms by gaining the electrons, by losing the electrons, as well as sharing the electrons. Which electrons? The valence electrons. Where are the valence electrons? They are present in the outermost energy level of the atom. Okay, in the outermost energy level on the we can say electron cloud. Okay, now why do atoms form bonds? Forming bonds allows atoms to fill their outermost energy level. Look at here. Actually, you see 2 elements are present, sodium and chlorine. Sodium, outermost energy level in sodium is not 8, but it has to be filled with 8 electrons, and it should reach the number of the electrons as 8. But is it 8? No, it has 1 electron as a valence electron. Now, either it should get the 7 electrons from outside, or it should give 1 electron to the another element to have fulfilled valence electron as an 8. Now, it is easy to give 1 electron than get 7 electrons from the other elements. That's why sodium tends to give 1 electron to another. How about the chlorine over here? It has how many valence electrons? 1, 2, 3, 4, 5, 6, and 7. 7 electrons it has. How many missing? Just 1 missing to reach the 8 electrons. That's why it gets 1 electron from the another elements to fill their valence electrons to 8. Understand? That's why chlorine gets 1 electron, sodium lose 1 electron, and they make ionic bond, and they make the bond and they become salt. Understand? That's why it is positively charged ion. Now it is negatively charged ion because 1 electron is extra for chlorine. 1 electron is missed from the sodium. Okay, an ion is a charged particle that forms when an atom loses or gains an electron. Okay, I explained before. This is sodium ion. This is chlorine ion. Why? Because they lost or gained electron. The ions formed by chlorine and sodium both have 8 valence electrons. Now they have both 8 valence electrons. Bonds hold the negative and positive ions together, producing sodium chloride. Okay, sodium chloride is table salt, we can say. Now there is a video over here. You are able to see. You see actually what happened here. The electrons are shared over here now, but in here it is also shared. Okay, electrons are shared in the water, but here it is not shared. It is transferred from one atom to another. Okay, Actually, one of them is sharing, another one is transferring the gaining or losing electrons. Okay, this is sharing electrons. Okay, like that. I think you got